I'm Uma. I'm one of the co-founders of Succinct, and today I'm going to be talking about the missing piece in accelerating ZK adoption, which is what we've been working on for the past few months. Okay, so today, as we all know, decentralized environments have really high computational overheads, and then on-chain applications are extremely limited in their compute resources. And applications are definitely made meaningfully worse from these constraints and often have to rely on centralized oracles or take other shortcuts in the name of gas efficiency or even making your application viable. So ZK, as we all probably know, is a very exciting topic. It's kind of gotten into the mainstream of blockchain and crypto in the past few years. And a zero-knowledge proof basically uses verifiable compute and provides limitless computation to application developers on blockchains. In the context of the EVM, you can think of a ZK proof as kind of the ultimate precompile, where a developer can take any computation that might take a ton of gas, generate a zero-knowledge proof for it, verify it on-chain for 200K gas, and then use that extremely expensive computation in their smart contract in a gas-efficient way. At Succinct, we've been working on ZK for the past year or so, and we think that the novel affordances of ZK will enable the next wave of on-chain innovation. So concrete examples of ZK-enabled applications include things like Lite clients, where instead of having a multi-sig bridge, you can have a ZK Lite client that verifies consensus of another chain, and you get trust minimized bridging between different domains. You have applications like ZK oracles of historical state or of validator statistics in the beacon layer. You can bring machine learning on chain and make that available to different applications. Obviously, privacy is a very well-known use case of ZK, and Tornado Cache and other applications like that are already in production today. And so there's a lot of stuff you can do with ZK that we think will be very powerful currently and in the next few years. And one interesting thing about ZK is that the field is advancing extremely rapidly. So every year, there's more and more advances. Proving time goes down by orders of magnitude. And we've seen this in the past few years, and the trend is only continuing. And so we're only at the cusp of what is possible with ZK. So at Succinct, as I mentioned, we've spent the last year building and deploying these next generation ZK applications to production. We are most well known for our Lite client work, including Telepathy, which is our ZK Ethereum Lite client that is used to help secure the bridge from Ethereum to Gnosis chain. More recently, we've been working with these L1 DA layers, such as Celestia and Avail, to build a ZK bridge for them and bring their state from their respective chains to Ethereum. More recently, we've been working with a few other teams in the space to do ZK oracles for computations that are too large scale to fit in the EVM. So for example, a team like Lido, they currently have a trusted oracle where they have a trusted oracle group of validators that basically read the beacon chain state and compute what is the balance in the Lido validators. But actually, you can generate a ZK proof for that computation, and we're working with them to generate the ZK oracle to replace their trustless oracle. And there's similar other applications that we're working with teams like Eigenlayer and Nouns and Ion on as well. So from our experience, we know that developing and deploying ZK to production is a total nightmare. And so now I'm going to talk more about the ZK landscape of today and kind of our firsthand experience with ZK application developers from our experiences over the past year. So I don't know if any of you guys have ever tried to develop with ZK, but one immediately striking thing about ZK development is that there is no mature developer tooling. So if you're trying to develop a ZK circuit, often these languages are super arcane, they lack documentation, they're scattered across many different repos, and your only option might be to go read the actual code to figure out what's going on. Often we've also found that if you're trying to use a particular circuit language, the actual primitives that maybe other teams have worked on in the past, there's no centralized repo of knowledge. So the only thing you can do is trawl through a bunch of GitHub repos, or maybe you're in a Telegram group that collects this information, but there is no methodical way to figure out what's going on with ZK. More practically, when you're trying to build with ZK and build your circuit, ZK has a lot of overhead, so builds and proving times are slow on local machines, and so you have to go to a remote machine, and there's a really convoluted development and testing process. And then also managing these version circuit artifacts and verifier contracts can be pretty error prone and time intensive as well. Okay, so if you've put in all that work and written a circuit, then you've only still done 20% of the work required to take a ZK application fully to production. So in production settings, teams often have to write other infrastructure like reliable relayers, on-demand scalable proof generation that scales with the number of proofs that you might need in any given hour. And then, of course, in production settings, liveness failures can be catastrophic, so you need to have extremely high availability. So overall, ZK development today is really difficult work. And at Succinct, we've personally observed the difficulties. We've kind of powered through them to push our ZK-like clients and other applications to production. But we also noticed that the difficulty of ZK development has influenced the ZK landscape in a more fundamental structural way. So today, because ZK development is so difficult and the bar for it is so high, right now, if you're an application developer and you want to use ZK in your app to make it better, you generally can't do it yourself because it requires so much expertise. And so there's this rise of this class of specialized ZK professionals, basically teams and companies exclusively focused on ZK, kind of like us, who make ZK apps or help apps who want to use ZK develop circuits. So most ZK apps today are written by ZK experts, and a lot of these teams have a variety of different approaches. Some teams use custom circuits, which can be really highly performant. Other teams have SDKs and DSLs for their specific use case. And then finally, some teams are trying to do ZK VMs, such as EVM or WASM or RISC-V. And the ZK VM is more general and flexible, but often can be slower. So even though all these different organizations and teams have different approaches, one uniting theme that we observed across the ZK ecosystem is that organizations generally build really monolithically. So if there's one ZK company out there that might be using Snarks with Halo 2, and then they also have to build out their entire proving stack and solve the whole problem of decentralized scalable proof generation, they'll have their own smart contracts on chain to verify proofs and have their apps integrate with. And then they'll build various other utilities like a proof explorer or reliable relayer infrastructure, all vertically integrated to their own stack. So the landscape of today looks like a bunch of siloed ZK teams fully building all this basically duplicate infrastructure specialized around their own proving stack and like their own needs. And one thing we realized at Succinct is that this monolithic approach has a lot of structural weaknesses. So one major weakness of the monolithic approach is that dApps have a lot of vendor lock-in. So in particular, because ZK development today is super monolithic and there's a bunch of siloed teams, there's no shared APIs or standards. So if you're a ZK app and you want to integrate a new solution, you have to learn custom tooling, and you often have to do a lot of bespoke integration work. Obviously, migrating between two different solutions requires a lot of effort because there's no standardization, and this increases the barrier to entry for ZK adoption. We've also observed this in our work where often application teams that we're helping, sometimes they need a small change in the circuit, or what we built isn't quite right for them. And their only option right now is to contact us over Telegram or Slack and ask us to make the changes. And there's no guarantee that, we'll make the changes you need. And in general, this results in less flexibility and increased coordination overhead. And then finally, the ZK space is extremely fast moving, as I mentioned. Prover times have gone down orders of magnitude every year. Different proving systems have come out that have dramatically made things better for different computational workloads. And because of this fast evolution, the optimal stack that people might want to use might change very quickly. And in a monolithic world where you have a bunch of these siloed teams, there's really high switching costs. And because of that, even if there's some new technology that comes out, that's really great. you might be too locked into your own stack, and you might be using previous generation technology because there's a lot of sunk cost. And so we think that fundamentally this monolithic architecture prevents adoption of the best ZK tech. So in all, from our own personal experience as people who build ZK applications, we've kind of observed that the difficulty of ZK development has led to kind of this monolithic siloed landscape with a lot of problems. And this results in worse outcomes for end applications that want to take advantage of ZK's power. So at Succinct, we thought a lot about this problem. We kind of observed the weaknesses, and we think that there is a different way. So in our vision for the future of ZK, which is something we spent a lot of time over the past few months coming up with, we kind of want to fix a lot of the problems with the current monolithic situation. So in particular, we think that there should be a set of shared APIs and standards for reduced friction for adoption. And in particular, say if a developer wants to switch between different implementations of proofs, they should be able to do so with one parameter change in their contracts. We also acknowledge that the ZK space often has novel algorithmic breakthroughs that can make proof efficiency improve by orders of magnitude. And similarly to the previous slide, developers should be able to modularly switch to the latest technology as the research and engineering advances. And then finally, our last kind of point in our vision is that we think that there will never be one proof system that rules them all. A lot of different proof systems are often really tailored to the use case. So for example, this proof system TensorPlonk, I actually think made by a Stanford grad student, delivered a 1000x speed up over a naive approach for ZKML. And we think that in the end game, a diversity of proof systems will reflect the diversity of use cases. And so there should be this shared proof system agnostic tooling that allows for all proof systems to benefit. So to realize our vision, which is pretty different from the current way current ZK teams are building their stacks and building their applications, we came up with a new architecture for ZK development and deployment. So the Succinct protocol is an open infrastructure layer with several minimally opinionated standards and proving system agnostic components that aim to solve kind of the vision that I outlined in the previous 3 slides and solve the problems of how people are building with ZK today. So the first component is this proof standard, which is this ERC-like standard that's really lightweight, minimally opinionated, that allows developers to link their smart contract and their on-chain logic with off-chain verifiable compute, and allows that verifiable compute to be done in any proving system. The next component is a proof marketplace, where it's an open marketplace where any prover can join, earn fees, and it will provide competitively priced, highly available, and decentralized proving to ZK applications. And then finally, we think the last component that is important is a universal aggregation protocol that aggregates proofs from a variety of different proof systems, and in the end will send the cost of verifying a proof on-chain to 0. So to talk more about the proof standard and how we imagine it, you can see here kind of this diagram where the proof standard is in the center. And then there's a bunch of different proof systems like Halo 2 is an example, Plonky 2, even a ZK WASM VM, where developers have this unified interface to request and consume any ZK proof from any proof system in the EVM. So more concretely, if you're a dApp developer, you can use the Succinct gateway in the proof standard, which is a single address on every chain, and it provides you a standardized interface where you can request for proofs, and then the proofs get generated off-chain, they get verified through the gateway, and then your smart contract receives these verified outputs post-proof verification. What's really nice is now the developer integration process is really standardized and simplified, because you have this interface that you just integrate with on any chain. You only have to worry about a single address. You don't have to worry about integrating with everyone's different standards for how you request proofs and receive outputs. And so it's really nice and makes the developers' lives a lot simpler. And then for proof systems, often a difficult part about using verifiable compute in your on-chain application is kind of doing the input-output between your on-chain bytes that go into the proof and like the the field elements that the proof system talks in. And so our proof standard at a very high level makes it so that as long as your proof system's public inputs adhere to a simple specification where it takes in input bytes and output bytes in a specific way, then any developer can use it through the Succinct gateway. And so if you're a proof system and you want to make it easier for developers to build with your proof system and use it on chain, then you can integrate with the standard and expand your distribution. So the proof standard is something that is like live today. It's a very simple contract. And as ZK application developers, we've been using it to make our live clients and oracles, and it's made our lives a lot easier. The next thing, the proof marketplace, is something that will probably be a little further down the line. We think that in the endgame, applications will require decentralized, highly available, cost-effective proving. And the best way to serve that need is an open proof market where provers can earn fees for joining and they can provide their compute. And an open marketplace is quite nice because it fosters competition for cost-effective hardware or cost-effective solutions. And so this is probably the best way to get the most competitively priced proving for ZK applications. And then this should say proof aggregator, but this is the last component of the Succinct protocol and infrastructure layer. And today, verifying a proof on chain is at least 200K gas. And something that's very interesting about ZK is you can verify another ZK proof in a ZK proof. So this technique is known as recursion, and it's powerful because you can further compress any computation and basically send the cost of verifying a proof on chain to zero, as the 200K gas cost gets amortized over a batch size of n proofs. So a proof system agnostic aggregator, where you can aggregate proofs from a variety of different proof systems, is really powerful because now instead of having 200K gas for verifying a proof, it's basically zero. And that can enable a wide range of a lot more applications. And so in our system, because all these proof systems are integrated with the proof standard, and there's a standard for the public inputs and outputs, it makes it a lot easier to aggregate proofs from a diversity of proof systems. So I've talked a lot about the protocol, which is kind of this more modular architecture for ZK development and deployment. And it's proof system agnostic, and it has a lot of this like shared infrastructure, like the aggregate and the marketplace for different proof systems. And now I want to talk about the Succinct platform, which is kind of like the front end for building with the Succinct protocol. So the architecture of the Succinct protocol is pretty unique, as I mentioned, because it's kind of this answer to the current monolithic landscape today. And the Succinct platform is also built with the same vision in mind. And the Succinct platform is live today. You can go check it out at alpha.succinct.xyz. And it's the easiest way for developers to build with ZK. So more concretely, what can you actually do on this platform? Well, there's a few parts of the experience. You can go to the platform if you're not a ZK developer, and you can discover what ZK applications are being built, and you can learn more about the latest advances and use cases of ZK technology. Then we have a bunch of tooling that uses our proof standard, and eventually we'll use our marketplace and our aggregator, where you can iterate quickly and develop with ZK using any proof system. So as you can see, our platform is built to be really modular from day one. And then we have a one-click deployment workflow and really reliable infrastructure for really easy and smooth usage in production settings. And so, yeah, there's a list of features for any proving stack that we made. So as you can see, we support any proving stack and provide any proving stack with all these utilities. So for example, you can create a project with GitHub, and we have nice collaboration tools. You can have really fast circuit builds in the cloud and version circuit artifact management. You have one-click deployments of your verifiers on any chain. Then once you've done all of that, you can integrate using the Succinct gateway with your on-chain application. And then we have managed infrastructure that one day will turn into the proof marketplace right now that is fulfilling proofs with high liveness. And then finally, this is the most important part, is you can share your project with the ZK community. So we give you a really nice link where you can just share your project and get featured as a trending project on the homepage and show the community kind of what is possible with ZK. And so the platform and the protocol work really well together to move us past kind of like the monolithic architectures of ZK today. So if you're a developer building with ZK, when you use the Succinct tooling and platform, you can easily switch between different ZK implementations because all of our tooling is proof system agnostic. And similarly, if a new proof system comes out or a new ZK VM comes out and it's really state of the art, our platform makes it really easy to support that new proof system. And so you can modularly switch to the latest technology. And then finally, like all our shared infrastructure, like our relayers, our proof explorer, our high liveness, like scale up, scale down proof generation is coordinated so that no matter the proof stack, all these different ZK proof systems can benefit from this tooling. And so we really hope that our protocols architecture and the platform's architecture, which we've built in mind to be really different from a lot of the other approaches in the ZK space, help accelerate ZK adoption and let people build a ZK in the most sustainable and best way possible. So there's a bunch of people using Succinct today. Some of the projects I mentioned, like Celestia and Avail, are using it for their ZK Lite clients. Some of the ZK Oracle use cases include people like Nouns for a particular prop they had. And then Eigenlayer is also using it for their protocol. So there's a lot of pretty interesting use cases that you can check out on the Discover panel of the platform today. And yeah, we think at Succinct, we're really bullish ZK. We think we're just at the tip of the iceberg in building new applications with ZK-enabled compute. Like identity, oracles, ML, like clients, that's just the start. There's probably a lot more that we can do, especially as the tooling gets better and better. And so if you're a dApp developer and you want to build your next generation ZK-powered application with Succinct, please reach out. And if you're a proof system and you want to integrate into this modular ZK stack and make it easier for the open source community to build with your tooling, then you should definitely reach out as well.